So in this video, we're going to talk about some derivative rules. And I want you to see this notation that you see right here, this d dx. That is another way to say take the derivative with respect to x, meaning x is the variable that we're working with. So if I wrote y, then I would be taking the derivative where my variable in that case would be y. So one of the first derivative rules that will be helpful for you, instead of having to go through the whole definition of derivatives, we're going to start out with c. So c in this case represents a constant function. If you think about a graph of a constant function, something like, I don't know, this function right here, let's call it y equals 2. This particular function, if you think about a slope of the tangent line to any point, the slope would be 0, no matter which point I take on this line. So anytime that you take a derivative of something that is a constant function, so if I did the derivative of 5, I would end up with 0 as my derivative. If you think about a case where I take a derivative of the graph y equals x, something like this, if I take a point that's on that line, remember that it's y equals x, so this graph would have a slope of 1, up 1 over 1. And that doesn't matter where I take a point, because this is y equals x, it would have a slope of up 1 over 1. So the derivative of x would just be 1. So those are some basic derivative rules, and that's something that I would expect you to know without having to run through the whole definition of a derivative. I want you to look at this next page here. I wrote down the derivatives of what happens for the function y equals x squared, y equals x cubed, and y equals x to the 4th. I'd like for you to pause the video here and try to see if you can come up with a pattern that you notice with these derivatives. So just take a second, pause the video here, and see if you can figure out a pattern. So hopefully what you saw is the exponent is the number that went out in front of the x. So each of these exponents went out in front of the x. And then hopefully the second thing that you noticed is that each one of the powers that you had got reduced by 1. Over here, this power for this one got reduced by 1. 3 minus 1 would give me x to the 2nd. Over here, 2 minus 1, that would give me x to the 1st. We don't write the x to the 1st, but as you could see it there. So in general, anytime you have one of these polynomial functions where we have x to the nth power, you take the power, put it in front of the variable, and then you take the exponent and you subtract 1 from it. We call this the power rule. So anytime you see something like this, instead of having to do the definition of the derivative, you can simply just use this power rule, which is awesome. Makes me so happy. And I'm sure it'll make you happy as well. All right, so let's just take a look at some examples so I can show you what would happen. Again, if I had x to the 6th power, remember f prime is another way to say take the derivative. I take the power, put it out front, I write down the variable, and I subtract 1 from the exponent here. So if I were to subtract 1, that would make it x to the 5th. Here's another notation for the derivative, y prime. And my function is x to the 1,000. I bring the 1,000 out in front, write down the variable, and subtract 1 from that power. Again, here is another notation for the derivative. So this says my function is y, and I want to take the derivative with respect to t. So t is the variable for this particular function. So again, I take the power, write down the variable, and subtract 1 from that exponent, so that would be 4 times t to the third. Now in a case like this, next one, we're going to take the derivative, and you will notice that it's not written as a variable to a power. If you recall from what we did previously, this is the same thing, this fraction, if I move the r up to the numerator as r to the negative first power. Because in the denominator here I have r to the first. If I move it from the denominator to the numerator, it changes and it becomes negative. So again, at this point, I've rewritten into the form that I know how to deal with. I take the negative 1, I put it out front, write down my variable, and I subtract 1 from the power. And I'm okay if you want to leave it your answer like this. If you want, you can put the negative exponent, make it positive, and put it in the denominator, but I'm okay if you leave it as the previous answer. So same idea for this next one. It always is helpful to start by writing it as x to some power. Now if you recall, this is a square root function, so technically there's a 2 on the outside. And on the inside here, this is like x to the first. So the way that it works is we raise x, and the fractional exponent will always be the power that it's being raised to over the root. So the x is being raised to the first, and the root is a square root. If it was a cube root, then it would be x to the 1/3 power. It depends on what kind of root you're working with as to what the denominator of that fraction would be. So once we get it in this format, then we simply just take the power, put it out front, multiply it by x. Now we need to subtract 1 from the power. So some of you can do this pretty easily in your head. If you can't get a common denominator, write this as 2 over 2. And 1 minus 2 would give you negative 1 over 2. And again, I'm okay if you want to leave it that way. If you choose to rewrite it, be careful. Since it's a negative exponent, it would go in the denominator. This is a square root, and it would be raised to the first power. So you could just write it just like this if you'd like, because it's assumed it's a square root and x is being raised to the first power. Okay, now that I've shown you a couple, I want to give you a couple to try that are similar to these last two, so you can just get the practice of rewriting them so we can use the power rule. I'd like for you to pause the video here and see if you can come up with what the derivative would be for each of these functions. Start first by rewriting it and then use the power rule. Okay, so this would be x to the negative second power. If I take the derivative, that would be f prime of x. I bring the power out front, negative 2x, and then I subtract 1 from the exponent. Again, you can leave it like that, or if you had to simplify it, you would write it like this. For the next function, what I would do is write it as x. Remember, it goes power over root. In this case, we have a square. The root is a 3. So I want to take the derivative of y. So I'm looking for y prime. I put the power out in front. Subtract 1 from the exponent, so subtract 3 over 3, which would be negative 1/3. Okay, again, you can leave it like this, or if you absolutely must rewrite it, you would have a cube root based off of this part right here, and x would be raised to the first power because I moved the negative into the denominator there. Okay, so either of those would be okay in this situation. Okay, now there's just a couple of rules that will make your life a little easier when you go to calculate derivatives. Again, if you know these rules, you don't have to use the big, huge limit definition of a derivative. You can simply just use these rules and it'll be a fast way for you to get the derivative. So let's say I have a situation where I have x to some power. We know with the power rule what to do with that. But if we end up multiplying it by a constant function, we've got to know what to do in those cases. So according to the constant multiple rule, what you're going to do is you're going to take the constant and you're going to put it out in front. And you're going to multiply it by the derivative of the x to the third. Kind of like when we did limits, we could take out the constant, we could pull it out in that case. So if I take the derivative of x to the third, the 3 comes out in front, the x, and then we subtract 1 from the power. So 7 times 3, that would give me 21 x squares. If you want to kind of do this in one step, take the exponent that you see, multiply it by the number out front, 7 times 3 is 21, and then just take off 1 from the power. And that's how you could do it in one step. Okay, one other little handy tidbit. If we know that two functions are differentiable, then when we add those two functions together and we take the derivative, that's the same thing as taking the derivative of the first function and adding it to the derivative of the second. Same would also be true with subtraction. I could take the derivative of the first thing and subtract it from the derivative of the second thing. So as you see here, again, I have two different functions that I'm working with. I can start by taking the derivative of the first function and subtracting it from the derivative of the second function. So you'll notice in this first case, I have a constant out in front. So if you want to use that constant multiple rule, take the exponent, which is a 2, multiply it by 3, that'll give me 6, write down my x, and then I subtract 1 from the power, so that would be x to the first. Now over on this side, we have x to the first power. So I bring the 1 out front, I have the x, I subtract 1 from the power, so that would be x to the 0. And so remember, on the left-hand side, I have 6x. On the right-hand side, one of the zeros is 1. 1 times 1 is 1. And so my derivative in this case for that whole function would be 6x minus 1. Okay, so these are the tools that I want you to work with in your tool belt, those different definitions that I gave you of the different rules. You will see on the next slide here, I have some problems that I would like you to try. So I want you to start out, pause the video, and I'd like for you to just try these two problems, and then I will forward the slide to the next one and have you try it again, pause the video, and then check to see what you would get for your solution. Okay, so in this first one, we're going to use our constant multiple rule. Again, we have a number out in front of the x. We're going to take the 3 and multiply it by 4, so that's going to give me 12. And then I write down the variable and I subtract 1 from the exponent. So my derivative here would be 12x to the third. Okay, same idea over on this one. This is like x to the first. I take 1 and I multiply it by -1. And then I have the x. I subtract 1 from the power. X to 0 is 1. 1 times -1 would give me -1. Okay, here is a challenge. Again, pause the video here, and I'd like for you to try this one. Okay, so we're going to start just by breaking up the function and taking the derivative of each of the pieces. So that's what I'm going to do. Just write down the derivative of each of these guys separated. Okay, so the derivative of x to the 8th, 8 comes out front, write down the x, subtract 1 from the power. For the next one, I take the 5, multiply it by 12, so that's 60, and then x to the 4th power, don't forget to subtract 1. 4 times 4 would give me 16, and then subtract 1 from the power, that would be x to the 3rd. The next one, 3 times 10 is 30, and then x to the 2nd power. This is like x to the 1st. 1 times 6 is 6, x to the 0. And then we have the derivative of a constant function. If you recall, the derivative of a constant function is 0. So just to simplify a little bit here, all of these guys are okay. But when I get to the end here, x to the 0, this is 1, so this is like -6. I don't need to include the plus 0 because it doesn't contribute anything to the derivative. So that would be the answer to your derivative in this case. All right, that is all that I have for the video for today. Have a great rest of the day.